Welcome back everyone. This is the latest update video for the Yaris intake. Today we're going to be looking at the CAD design. We're also going to be looking at the prototyping and then the testing in the car between the stock gearbox and the prototype for intake temperatures. So the first step is to look at the 3D scans which we did in the last video. As you can see here, the 3D scans are all assembled on my screen. We've got the stock gearbox, some part of the engine cover just for reference, the front area, and obviously the rear tube. So the scan gives me a very good envelope in which to design. I can pick off all the reference points and create planes where I need to then start my development work. So I've already obviously designed these pieces. I'm just going to hide the airbox and show you to start with the rear tube. So this is the stock rear tube for the GR Yaris. Now when I was developing the housing to connect to this tube, we are removing the convoluted rubber piece because it's not very good for airflow at all. So our housing will be connected to the MAF tube, and then that will straight away connect to this rear section without a convoluted flexible hose. Now the problem with this stock rear tube is where it ends up. That means I have to have a much sharper bend here to then point to the front for the duct. So we've redeveloped this tube to give us a nicer ending point. So I'll bring up our tube so you can see the difference. Okay, so the yellow tube is our redeveloped tube, and you can see the angle where it ends up as compared to the stock one. The bend is also much smoother through our tube versus a stock one, which has a sharper bend. Now that tube, we'll show you later, we have prototyped it in metal, in aluminium and in plastic. And we'll explain that later. So that's the rear tube, gives you a much nicer bend profile and gives me a better starting point to start the housing. And that's the main part of this design. So the housing, now you can see we've got a solid connection between the housing and the tube. There is no flexible rubber hosing in between, which is horrible for airflow. So we're keeping the airflow as smooth as possible. We've got our MAF section here. So the MAF sensor sits in there with a machine part which goes on top. The housing itself, you can see we're using as much as possible of that area in the engine. This is the largest housing we could have made for the filters we have. It uses our largest filter, capable of 1,000 horsepower. I'll bring up the filter so you can see everything in assembly. That's the filter in the housing. It's our patented design, so it's a reverse mounted filter. Gives it a Venturi effect, so essentially you've got a much smoother flow profile, sorry. So everything is nice and smooth and laminar as it hits the MAF sensor, and that continues around into the rear tube. So the final piece is the duct. The duct connects the housing to the front where it draws air in, so you're sealing it from the heat of the engine bay. We did make two different ducts. So I'll show you one duct. That's our duct, and there is a gap you can see here, but the gap will be taken up with a flexible rubber seal. So as the engine moves back and forth, that movement is taken into account with that rubber seal. It expands, so the housing moves back and forth with the engine, but the rubber seal allows the seal to be intact. So the duct you can see here, this one has that secondary opening, and there's a a tubing which goes from that down into the area where there's like another input. We'll show you that second feed later on. So there's two duct designs. There's this one with that second feed, and it's also the same design without that second feed. And we'll test both in the car and then show you the results of that. That's a nice illustration of a cross section straight through the middle of the filter to show you how the air will navigate through the system. So in the stock system, the airflow has to come from the front here, then it has to go into the airbox, goes up through the stock panel filter, which is square, and then that's a 90-degree turn, then turns again 90 degrees to go into the tube. In our design, it's all very linear. So you've got your airflow coming in through the front of the duct, through the section here, goes straight through the filter, navigates around the filter, and then into the MAF section, and then straight into the rear tube. So it's all very direct, it's all very linear. It allows the airflow to remain as laminar as possible, which allows the turbo to work more efficiently. There's less drag on the turbo. So as part of the design development, we also look at some CFD analysis. CFD analysis is basically computational fluid dynamics. It allows us to simulate airflow through the system, so we can identify areas of improvement where there's lots of turbulence. Also allows us to see if we can optimize geometry with curves and try to shape the airflow to be more laminar. So on my screen, I've got a mock-up of the stock Yaris airbox. I'll just run through the model quickly. I haven't modeled the duct in its entirety because we just need the input. So we've got that's the duct which goes to the front there. I've made an opening here for that secondary flap. Then the red mesh you see here is the filter, which is modeled in computational fluid dynamics with a porous medium. So you've got the lower half of the airbox, the upper half of the airbox, and then the tube which comes out of the airbox, which is your MAF section. Also this convoluted tube here, which is the rubber hose with all the corrugations in it. Finally then, that rear tube at the back. So with the entire system modelled, we have run an analysis, and I'll show you a couple of cut plots of velocity through the system. Okay, here's the first one. So that plot is through the initial duct. It's a 2D plot. It shows you arrows which are velocity arrows. You can see the trajectory of flow. As you can see, the airflow comes in through that duct. It has to then negotiate 90 degrees upwards through that panel filter. So that's the panel filter there. It then goes up and again has to go through that tube. This plot is showing as that flap opens up. So we've left it open for the benefit of the airbox in the analysis. Again, you can see lots of 90-degree turns through the bottom of the airbox, up and then through the tube. I think more clarity will be shown with some trajectory profiles. So, okay. This is a 3D flow trajectory. So you can see the flow in its entirety. I'll start from the lower half first. Okay. As you can see, lots of turbulence, lots of vortices as that flow comes in through the duct. That's both ducts. This is because the airbox is essentially a cuboid shape, and wherever you've got corners, you will always get vortices and turbulence. As you can see, the flow goes up through the filter, and then the most important part of this analysis is that tube section. So we've got the flow coming through the MAF section, going through the corrugated tubing, and then through the back tube here. Flow, the color of these arrows depicts the velocity. So red means it's quicker, green and blue is slower. What we're looking for is a nice even color profile, so a nice even velocity profile through the tube. The more even it is, the more developed that flow is, which means the flow in the tube is more full, if you like. It's not unbalanced. So that's your cut profile through the top section. Just grab that section there. It's showing you what it looks like through the top tube, the corrugated tube. This is why we don't like corrugated tubes, because you've got so many flat faces which the flow bounces off, and then eventually through the back tube into the turbo. So now the Eventuri intake, as I explained earlier, is a lot more direct. You haven't got a panel filter, you haven't got a square airbox, so the flow is literally coming in through that front duct, going straight through the filter, which is our reverse mounted design, and then straight into that rear tube. So in effect, the flow isn't having to negotiate multiple turns to get through the filter and then through into the rear tube. First of all, through that duct and filter, as you can see, the flow is coming straight in. Arrows are nice and straight. It's not having to go up and down through multiple turns, straight through the filter, and then starts negotiating to the tube. There is a bit of turbulence in the duct, but that's to be expected because of the geometry of the system. However, the important part is as it enters the filter and what it does after the filter through the rear tubing section to the turbo. So you can see here, unlike the stock system, it's a lot more balanced. We don't have a high proportion of high velocity in the middle section and then, arrows in multiple directions. It's nice and even. The flow is much more developed, and this will be more apparent with this cut profile. You can see we've got a bit of a high spot at that the bend on the inner radius, but it's a lot more developed, a lot more even flow profile. The velocity is much more even, which is much better for the turbo. It means it's less drag. It's using the entire volume of the tube rather than just the middle part or sections of it. Okay, I've now got both the Eventuri intake after the duct and the stock system. Again, we're not looking at the duct, so we're looking at the flow through and after the filter, and then through the MAF section, and then through into the back tube. So there's a very clear difference between the two here. In the stock system, your flow profile, there's a lot more gradient, so you've got a high concentration of high velocities through that middle tube, and then as it goes through the back tube into the turbo, you can see how the flow is trying to negotiate that sharp turn. Now, it hasn't had the opportunity to negotiate that bend as smoothly as it's got in the Eventuri, because in the Eventuri system, the flow's got more time to develop because it's not having to negotiate up 90 degrees and up again, through again 90 degrees through that panel filter. It's going through the conical filter, and it's got a much gradual curve here, which is why we redeveloped that rear tube. You can see here clearly that radius is a lot bigger, so you haven't got such a sharp turn. That sharp turn there is giving rise to this turbulence in this section of the tube, which just means that it's creating more drag in the overall system, which isn't as efficient for airflow. So overall, our CFD analysis shows that the Eventuri system is better for flow. It allows the turbo to pull air with less drag, which in the end means that it will be able to produce its peak boost earlier. We'll show you that later on. So the next step is to send these designs to our 3D printers. We can print the housing, the duct, and the plastic version of the rear tube. We've already fabricated the brackets in stainless steel, so they're ready to go on. Obviously, we have the filter and the filter assembly ready. We'll take these now to the 3D printers and get them printed in plastic. So we finished printing the housing, the prototype housing. It's all assembled with the filter, the bracket, the cowl, and obviously the silicon. We're going to put this into the car, but before we do that, we'll just talk about the stock system. So we've just finished testing the stock airbox for inlet temperatures. The way we tested it is using this thermocouple wire. The thermocouple probe goes into the back of this tube at the back here. This is a plastic tube which is connected to the stock airbox with this flexible rubber hose. The thermocouple is plugged in right at the back of that tube, and it's in the middle of the tube. So we finished testing this. It's interesting to see what's happened, which we'll discuss afterwards. It's very interesting to see what the flap here has also done. So after a certain RPM, there's a vacuum controlled flap here which opens up and allows in more air. But obviously, being in the engine bay, it's going to allow in warm air rather than ambient temperature air. So we'll discuss the results of that afterwards. I'm going to remove this now and start installing the prototype Eventuri system. So we've removed the stock system. The first part which we're going to install is our rear tube. Now, since it goes around the back of the engine and it's pretty much on top of the exhaust manifold and turbo, we're going to experiment with using either a metal tube or a plastic tube. So the test here is going to be in terms of heat. Which one will be better? Obviously, metal will soak up heat quite faster, but with the car on and the car running, pulling air through, we need to test which one's actually better on the road when it's on full throttle. The reason for doing that instead of carbon is to keep the cost down, because you're not really going to see it that much. So we're just going to make sure we choose the best material for this purpose. Okay, with the tube in, next is the actual housing itself. So, as we explained earlier, it's the largest filter that we have. It's capable of supporting up to 1,000 horsepower. Obviously, we're not going to get to that sort of level with this car, but for any future developments, it's more than capable. The housing itself is our patented design with our reverse-mounted cone filter, which allows the airflow to stay laminar throughout the tube. It's also one piece with the mouth section, so there's no intermediate joins, which again is better for airflow. It's nice and smooth, there's no steps. We've kept it as big as possible, so there's a recess here for some wiring and hosing in the engine bay. So we'll put this in, and then the last thing will be the duct. Right, housing's in. Last thing is the duct. Now I've got two designs here. This one has a secondary inlet with this sort of flexible tube at the bottom of the duct, and this one is closed off basically. Now, the reasoning for trying this is because at the front of the car, right here next to the intercooler, there's a duct opening, and that comes through into the engine bay. It's difficult to see, but it's literally right down at the bottom there. Now, that opening is facing the gearbox, and you can see on the gearbox there are some cooling fins. So more than anything, that thing is really good for cooling down the gearbox itself. The stock gearbox does open up in this area to feed when that vacuum flap opens up. So we're going to experiment to see what happens with that secondary inlet, to see the effect it has on temperature. Even though there's cold air feed down there, will the temperatures rise with that secondary feed or not? So that's our second duct design. I'm going to put that in now and we'll go for a test. I've installed the intake now. We'll have a quick look at the system. So the rear tube's been replaced. Also, that flexible rubber corrugated tube between the airbox and the tube has gone. It's all nice and smooth. There are no ridges in the way now. Now, that flexible tube did have a purpose for movement. So as the engine moved back and forth, that stock flexible tube took that movement. What we've done is allowed this housing to move. So as the engine rocks back and forth, The housing also is allowed to move back and forth, but the seal is kept with this flexible rubber seal here. So the duct is mounted to the chassis, which doesn't move, yet this can move independently, and the seal is still there. So we don't have that problem with the airflow hitting a long section of corrugated hosing. That's that housing part. The duct itself, this one is got the secondary inlet. It's also really nice and straight. So unlike the stock airbox, we've got a small feed which goes into the front, then it goes up the airbox through the panel filter, again 90 degrees turn to the tube. Everything here is now very, very straight and direct. There are no 90-degree turns for the airflow to negotiate. What we've also done with the duct is not restricted it to that small opening in the front of the grille. There's an opening here which is very, very close to the bonnet shut, so this area of the engine is very cold. That de-restricts the duct compared to the stock duct, so we don't need that extra flap opening up as the stock system does. We'll now test this with the secondary inlet. We'll then swap that out, put the other duct in without the secondary inlet. Depending on which one is better for temperature, we'll keep that one and then we'll change the rear tube. So a nice byproduct of de-restricting the intake system is that we release the sound of the turbo. That's a really important thing to mention there, because I think often people assume that on a performance car the OEM manufacturers optimize the airbox for performance, but in actual fact they don't. The airbox, the primary reason or the primary goal for an airbox is filtration and noise. OEM manufacturers use an airbox to attenuate the noise because they have strict regulations to conform to. Noise is very important for them to dampen. So when an OEM manufacturer, be it for an M3, M5 or the Yaris, any high performance car, that airbox is there to muffle the sound from the engine or the turbo. So they're not looking to get maximum power out of the airbox, so they're not bothered about optimizing the airflow through the airbox. That's what we do. And that's why we can improve on it, because we're not bothered about sound in terms of attenuating it. We're trying to improve the sound, but we're not looking at that as our primary goal. Our primary goal is to improve the performance and the airflow. And a byproduct of that is we release the sound. So having seen the analysis of the intake systems, we've shown you the prototyping stage. We've also mentioned throughout the video of data collection with intake temperatures. We will now be showing that as a separate video because we want to go into that as a deep analysis. So I want to detail what we've seen with intake temperatures. It's very interesting, but it's going to take quite some time to do. So that video will be coming up next as a separate video. For now, we're done with development. Next stage, as you will see, will be data analysis.
Thank you so much for watching, guys. If you'd like to watch more of this project, you can do so over here. If you'd like to watch what YouTube suggests you might like from our other videos, you can watch that over here. If you like this video, please click on the thumbs up. And if you haven't already, please subscribe to our channel. If you guys have any questions, please drop them in the comment section and we'll do our best to answer them for you.